compositions and transformations, a combination of two or more transformations where the first transformation is done on the second transformation. Getting stuff right. And that's really all the definitions we got today. We just gonna be actually practicing. That's all we're doing. Oh, we did leave it like that. Hold on, I'm looking at something. Oh, good, we changed it. Alright. So directions, graph, and label each figure and its image under a given transformation. The first one, triangle X, Y, Z with vertices of X, -3, 7. I'm not reading those. We're graphing that. They want us to reflect it over the X-axis, followed by which is a translation, everybody should notice that, of XY mapping to X plus 9, Y plus 2. So that's what we're about to do. Graph the pre-image. -3 up 7. -2 1. And -5 2. X, Y, and Z. I'm gonna be moving faster today. I usually pause and stuff, but y'all be moving quicker than me now, so I'm not gonna be waiting on y'all to draw no figure. Honestly, most of y'all move faster than me. First thing I want us to do is reflect over the X-axis. Now y'all know y'all got two options on that. You can either count it like I do, or you can use the reflection rule if you remember what the reflection rule is. This is an easy count, so I'm gonna just count it real quick. X was 7 up, going 7 down. X prime. Y was 1 up, 1 down. Y prime. Should have changed my color. I'll do it on the next problem. Z was 1 up, 2 up, I'm going 2 down. Z prime. That's my reflection over the X-axis. I'm writing those coordinates down over here real quick. You see we got 2 spots here too for coordinates. We're doing that right now, but I'll tell you when we get ready to take our testing and stuff, and you'll be used to it by then. We're only gonna want the final coordinates, not the. Right now, I'm gonna have y'all write all of them just so you can see how they keep changing. But when we do these transformations later on, these compositions, we're not going to ask you for 2 different sets of coordinates. We're only going to ask you for the final ones of that final image after you do all of the transformations. Right now they're asking us for these, so it's -3, -7, -2, -1, and -5, -2. Then after that, they asked me to do a translation: x plus 9, y plus 2. So, and this is what some of y'all messed up, some of these kids. You're going from the last image that you did. So a lot of kids thought they were supposed to go back to the original image and do a translation from that. No, that's not the point of this. Composition, you moving from here to here, and then you're going to move this image to the next spot. You just keep going with the last image that you used. Don't go back to the original image and do the next thing. No, that's wrong. The image that you just finished moving, go to that image, and that's what you're going to do next. I'm going to translate this second image that I got on here. So it's x plus 9, y plus 2. You can count that if you want it. I ain't counting. I'm going to just do the math real quick. Plus 9, plus 9, plus 9. What's this? Plus 2, plus 2, plus 2. It's going to give me 6, comma, negative 5, 7, comma, 1, and 4, comma, 0. I think I'm right. Yeah, I am right. And I'm going to just do the math instead of counting those points. You can count points if you want. I told you, I got options on translations. But I ain't doing that, because I know my math. These new coordinates here, you should see that they got 2 prime notations on them. We call these double primes. Obviously, we're doing this so you can distinguish between your shapes. Even though all my shapes are the same color, once I finish, I'll know which one I started with because of my notation and which one was my final. 6, negative 5. So 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5 here. This is x double prime. 7, 1, 7, up 1. Y double prime. Z is 4, 0. Z double prime. So once again, I got 3 images on the graph. For me, it's easy for me to distinguish which one I started, which one I finished with, because I notated all my stuff right. When I see some of y'all papers, I don't know what's what because y'all don't do the notation. That's why I be marking y'all stuff wrong, because if I can't figure it out, I'm marking it wrong. Yeah, rolling on. Doing another one. Obviously, I'm just hitting examples for y'all. Next one is this rectangle. They want us to rotate it 270, then translate it -7, 3. So y'all need to be able to recognize what rules they're asking you to use. On the first one, you should have recognized that as a reflection and a translation. On this one, just by looking at this, you should recognize it as a rotation, then a translation, just by the way they wrote the stuff. If you can't recognize that, then you're going to be in some serious trouble. Oh, FYI too, while we at it, the last 4 questions on your test are all compositions, like these. Some of you going to have to do 3 things in one, so you have 4 images on your graph. But the expectation is you should know how to do it. 1, 5, 7, 5. 7, 2, 1, 2. If they call your image a rectangle and you graph it and it ain't a rectangle, you know you did a point wrong. Some of y'all be drawing some crazy figures sometimes, and then they'll say it's a rectangle or a square. You know what a rectangle should look like. Like, I'm gonna try to keep pace, but if you want to, you can go ahead. I mean, like, some of y'all probably know what to do already. I'm doing this for the kids and maybe missed one or two things, a reflection on a translation. Maybe they'll pick it up as we go. It's pretty self-explanatory at this point. Rotating 270. Billy, which direction I'm going? Can't hear you. I can't hear you. Thank you, man. Counterclockwise. How many turns? Who? 1, 2, 3. Write my stuff down here at the bottom. I don't know what I did with my pen. So start with W prime, and this is around the origin, so our points aren't going to change on this one. This isn't a point not on the origin, so we should be straight when we get these. W prime, I got it as 5, -1. What is it? X next. X, I got it at 5, -7. Y, I got it at 2, -7. And then Z, I got it at 2, -1. Turning back straight. Graphing those. So W prime, we said 5, -1. W prime. X prime, 5, -7. Y prime, 2, -7. Z prime, 2, -1. My graph there. So yeah, that's me after my rotation 270 counterclockwise. Then I'm gonna write those coordinates over here because these are the actuals too. 5, -1, 5, -7. What's it? 2, -7, and then 2, -1. Oh, my bad. Putting those over here. Then they told me to translate. They use vector notation, but they said translate. How do I know it's translation? Common sense will tell you, capital T, they tell you to translate. And they said -7, 3. Once again, I'm not counting that because I don't be feeling like counting. I'm subtracting 7 from each X. And I'm going to add a 3 to my Y's. And I'm going to just calculate my new coordinates. In my head, that's -2, comma 2. That's -2, comma -4. That is -5, comma -4. And then -5, comma +2. These are my coordinates after the translation. With me doing my calculations, graphing. So -2, 2. That's W prime. or W double prime, negative 2, negative 4, 1, 2, 3, 4. That's going to be X double prime, negative 5, negative 4. That's going to be my Y. Negative 5, 2. That is going to be my Z double prime. Once again, if you're doing these right, since these are rigid motions, your shape should never change. You should just be changing the orientation of it. At some point, if your shape changes, you know you did something wrong. Don't turn that answer into me. Common sense will tell you, don't turn nothing in that don't look alike. You might as well just go back and rework it. You're wasting your time by turning it into me wrong. Alright, I got my coordinates because I calculated those, so I'm good. Moving on. Just light work. On the back. Number 3. So on this one, they want to know the coordinates of the image after rotation 180, followed by reflection over y equals negative 1. Y'all don't need me to do it. Rotate 180, then reflect your image over y equals negative 1. Alright, so this was our image after the rotation of 180 and the reflection over the line y equals negative 1. Minimize. Alright, last part, some new stuff. We're going to get a little bit more heavy into this the next couple units. But congruency statements. So based on knowing shapes are the same size and the same shape, if you have two shapes on a graph, you can make what is called a congruency statement about those shapes just based on knowing the shape. The shapes are exactly the same and they're exactly the same size. Sometimes they don't use, like we've been doing, the same letters for both shapes. The two shapes will be identical, but they may change the letters. They may call one ABC, the other one they may call DEF. But for y'all, since y'all know what corresponding parts look like, or corresponding angles look like at this point, y'all should know what corresponding parts look like too. So number 4 says, using the diagram on the right, write a congruency statement for the two figures in each coordinate grid. Then select the congruency transformation that maps one figure onto the other. So let's talk about a congruency statement first. Looking at these two figures over here, they look to be the same, yes? Alright, so that means they got points on each one that match up with each other. When you're making a congruency statement, it doesn't matter whatever you name your first figure. You can name your first figure any way you want to name it. But how you name that first figure, you have to name that second figure the same way so they match up, so the stuff matches up. So this first figure, they called it triangle JQV. This first one here, they call this triangle JQV. If they call that, what would you have to call the second triangle? Somebody? Besides Tim? Chandler. Sweetheart. The second triangle has different letters.
Oh.
You missed everything I just said, didn't you?
Yeah.
Okay. Somebody else, and not Tim. If we're gonna call, if they're gonna call this triangle JQV, what would you have to call the other triangle? Raise your hand if you're gonna volunteer. What you said, Rama? E what? No. Y'all gonna make Tim do this?
I'm not answering no more questions.
Luis? Lucia, sorry. Y'all lost in the sauce right now. And I'm on video. Nobody. I'm not like setting y'all up. This is easy. They call this first triangle JQV. Based on the way they named that triangle, you gotta name the other triangle identically. What would you name this other triangle? Yes.
EW.
Oh my god, I say that.
What?
I'll do it. Nobody gonna do it for me. Triangle EWT.
Oh. Man.
Like, I don't know what's wrong with y'all vision. Y'all can't think that J to Q is the same as E to T. Those don't even look the same now. One looks longer than the other. They went from J to Q to Q to V on this one. On this one, you would have to go from E to W to T. This can't be that hard. If y'all gonna struggle with this, y'all ain't gonna like, what is it, the next unit that we get into? Yeah, congruency. Jesus, yeah, we might well throw the whole next unit away. Y'all can't, this is simple stuff. But I told y'all, my goal this year is to teach y'all common sense. That's my goal, man, every year. Teach y'all kids common sense. It's not your fault, though. Y'all haven't developed it yet. The world has been too easy for you. Google has made you a bad person, but I'm gonna make you a good person. Alright. So that would be my congruency statement. Triangle JQV is congruent to triangle EWT, based on the way they called the first one. After that, they want to know what transformations happen to get this figure, JQV, to land where this figure is, EWT. How do they get there? They give you options. And say a translation, I'm going to tell you right now, on this one, a translation is wrong. If I slide this figure over, it won't match up. I have to do more than a translation. A reflection, you could think of it as a reflection over y equals x, but that ain't going to match up when you flip it up, though. So no, a rotation is possible, but when I rotate this figure up to this quadrant right here, it's going to be upside down of what this figure is. I'm sorry, when I rotate this up, like my Q is going to be way up here, my V is going to be over here, my J is going to be down here, it's going to be upside down. That ain't it either. This one is one you haven't heard of yet, but you will see it again before we finish this unit. Yeah, go ahead. This is called a glide reflection. That's exactly how it sounds. What happens is your image, they're saying glide like slide, so your image translates to whatever position it has to. This image probably translated up, I can count it for you. 1, 2, 3, 4, 5. Sorry. Went 5 up. And then once it got there, you would have probably had your image. I'm going to try to draw it a little bit. Not the best drawing. That triangle would have had to reflect over the y-axis. So slide up, then reflect over the y-axis. This is a glide reflection that you're looking at. That is what one looks like. We'll see it again, though. I'm going to talk about it Monday, Tuesday, Wednesday, all next week. That one's a little harder to spot. Number 5, y'all should be able to spot this, though. What happened here. Hopefully I'll do better with my congruency statement, too. Number 5, same thing. First, we want to write a congruency statement with triangle LMN and this other triangle. Emra, don't embarrass us again. The first triangle is called LMN. What would you have to name the second one? Wait. Triangle RST. Thank you, sir. I'm glad we didn't make that difficult. And then Emra, which transformation you think happened here? Say it louder. A rotation. Be specific. What kind of rotation? You can see it even without. Exactly. This is a 180-degree rotation. Everybody should notice that. Went from here to over here. Did 2 turns. Turned up here, then turned here. That's easy. That's a 180-degree rotation. Everybody should be able to notice. The last one, number 6. And honestly, too, I know for a fact we're going to put one of these questions on your test. It's not a hard question to do. You're going to have graph paper anyway. Let me start this. I might want to come back and look at this at some point. But I'm going to use one of these graphs we already got to show you what I'm going to show you. I'm going to just write in red on it or something like that. Number 6, it says the composition of a translation of 0, 4 followed by a reflection of a y equals 2 can be written as circle 1. So what they're saying is they got a composition of transformations here. They got 2 different transformations they want to do on an image. They want to know they want to know what single transformation would that be the same as doing. So let me show you what you would do. To test that out, you would just pick any point you want, because honestly, whenever you do these 2 transformations, it should still work out to one of these single transformations here. I know I'm saying a lot, but it's better to show you. So I'm gonna just literally just put a point on the graph. And I'm gonna use this graph right here because I don't want to use another graph, and I'm not about to give all y'all graph paper for this one problem. On this graph, I'm gonna just put point A here, and I'm gonna test this theory out that they have down here. Point A, they told me to translate it 0, 4. 0, 4 is how am I moving point A? 4 up. Thank you, Tim. I'm glad you answered another question. So go up 4, that would be A prime. Then after that, they said reflect it over y equals 2. Y equals 2 is right here. So I'm gonna draw a line of reflection in real quick. And I'm just testing this out on this graph. My bad. That's y equals 2. They want me to reflect that point over y equals 2. Reflecting over y equals 2 would be, okay, it's up 1, 2, 3 from that line of reflection, so I'm going to go down 1, 2, 3. And this will be my A double prime. Alright. So, the question is, I did 2 transformations there. I did the translation up 4, and I did the reflection of y equals 2. They want to know, instead of doing those 2 transformations to get to A double prime, what single transformation could I do to get from A prime to A double prime? So just look at these 2 now. What single transformation could I do just to get from here to here? Anybody got an idea? Is it Tim again? No? Okay, that's fine. Oh, Emra. No. Your options are down here, man. These are all reflections, too. What single reflection could I do to get from A to A double prime? Oh, new guy. Isaiah, that's it. I'm sorry. Huh? Who? B? B is a reflection over y equals negative 2. That's way down here. No. I can't hear you. E. I agree. E is a reflection over y equals 0. Isn't this, I'm going to highlight it. Isn't this my y equals 0 line right here? I told y'all y equals 0 is the same as reflecting over what? When we did our notes. Somebody, not anybody, everybody. Y equals 0 is the same thing as saying reflect over what? The x-axis, right? Yeah. So that's what it's saying. I know it's a complicated problem, but all they're asking you is, what single transformation could you do to get you from A to A double prime versus doing these two? And you would just have to test it out like I did. Test it out and then see what it would be, and then once you see it, you'll be like, okay, I can just reflect over this to get from A to A double prime. All you gotta do is use a single point on a graph, mess around with whatever translations they're telling you to do, and then figure out what that is. We're gonna practice another one like that before it's all said and done, because you will see one like that on your test where you have to do a test yourself and figure out what the answer is. But yeah, this one is E. Reflecting over Y equals 0. Alright, I'm real long-winded with that, I'm sorry. But I am going to give you some relief right now. Some of y'all